This is where we left off from last week. And this week we definitely want to continue with the math review and complete it. And then let's now go on. The next operator to talk about for relation is called overriding. And we're going to use the same relation as the running example to show you some intuitive example. And the overriding operator, if you look at its definition, which we'll show you in a moment, it looks a little bit tricky, but it's not too bad. You definitely need some example, and that will give you some exercise on deriving its property. And then in the next slides, we'll definitely get both practices solved for you. Right, let's take a look at the definition for overriding. Intuitively, okay, informally. So whenever we talk about overriding of a relation R, we want to say it's an overriding within another relation T. Okay, you can see there's a T over here. So we say a relation which agrees with T within the domain of T. So that's the first part. Okay, overall it's going to be relation as an output for the relational overriding. So the first part is the relation is going to consist of T itself, if that's within the domain of T. Okay, and then agrees with R outside the domain of T. Right? That's kind of the informal definition. Let's look at the formal one. Maybe that would be better for you. Okay, so this will be the definition. First of all, let me clarify the symbol, the syntax over here. This symbol here might look like something we learned earlier last week. Okay, remember which one it is? Look at the minus over here, right? You can see the minus actually crosses the third side, the vertical side of the triangle, right? Rather than stay completely within the triangle. So can you remember what the operator is? It should be the domain subtraction, right? So let me clarify this right away. They're different operators. They somehow just happen to look similar. Okay, let's now take a look. So what we learned last week was a symbol like this. Remember, there's a triangle we got, and then we got just this, like a minus, right? So this is so-called relation. Actually, it's called the domain restriction. It's pointing to the domain side, right, for the relation. And whenever you want to actually do it, you're gonna pass maybe a certain set for the domain value and also the relation R, right? So this is called domain subtraction. You can definitely look at the definition and example in your earlier lecture recording. Okay, so domain subtraction. And what I want to point out is about the types for the operands, which is very important. The R over here definitely is a relation, for sure. On the other hand, the S over here is not a relation. It's only a set. Okay, only a set. And the set, presumably, the set over here should be something about domain value, so you can subtract from R over here. Okay, and the new operator we are talking about right now for the overriding, let me use a different color. Okay, it looks like this. Okay, we still got our triangle like this, but now the subtract is more like this. All right, so that's the difference, right? Let's now take a look at the side, right? And also, if you go back to the syntax over here, we're gonna have R over here on the left side rather than the right side, right? So we're gonna have R over here. Let me use the same color. So we got R over here, and also we got T. Okay, so R over here is a relation. R over here is a relation. It's going to be with an overridden by. Overridden by another relation. Right? Syntactically, you really want to distinguish between the difference, right? You gotta have a sharp eyes whenever you actually look at the two operators, right? Just make sure you actually understand it, right? So this will be overriding. Okay, overriding. Okay, you can either say it's the overriding, it's an overriding operator. You can say R is overridden by T. Okay, that's how you pronounce it. Let's now go back to see the definition over here. Right, so that's basically it's going to be overall a set of order pairs. Remember, the very definition for a relation is going to be a set of order pairs, right? Every pair in that is going to be either satisfying this condition over here or this condition over here, right? You can see this is a disjunction, right? So you can think about this one over here. is really talking about this side over here. And this part over here is really formulating this side over here, right? Let's now see exactly what they really mean, okay? The first kind of order pair that will be included in the final relation is going to be just T, right? It's going to be included, right? Given that dr is actually a member of T over here, right? And also, it's going to include all those dr pairs in R as long as the domain value is not in the domain of T. Intuitively, you actually want to make sure this part over here is a relation, and this part over here is just another relation. We want to make sure the domains of the two relations do not overlap. So that's why you can see one part here is just about the domain of T, and the other part is about not the domain of T. So if you actually union them together in some way, remember when we talk about union operator, we use the disjunction. So you try to when you try to reunion these two relations, you don't really get any overlap, duplicates, you know, for the domain value, right? All right, so that's the definition. You can definitely study more closely on that, but let's now take a look at one example together, right? So that's the example I want to go over with you according to the definition over here. Let's take a look. Okay, again, make sure you can distinguish between two operators that look similar syntactically, but semantically they're very different. They're different operators, right? Especially here, you can see one is about a set, and the other two is about two relations, right? Let's now take a look at for the example we have for relational overriding. Okay, so over here we have the relation R over here, and then we want let's have the definition aside, but I want to just annotate very quickly. You can think about this part over here is one relation, and this part over here, as I said before, this is just another relation. Okay, let me write properly. Another relation. And this part over here is really about union. To union the two relations together, each relation is simply a set of ordered pairs. The union is just another set, like a bigger set, presumably. All right. And we're going to see how we can calculate this relational overriding over here. Right, let's take a look. Let me write from scratch. It's going to be R overridden by this particular relation, which would be just another set of ordered pairs, A3 and also C4. All right, and this is how I will recommend you actually how to really calculate the relational overriding. You want to focus first of all about of course this part, this relation over here is the T that we talk about, right? And we know the domain of T is simply A and C, right? Let's write it down. You want to know what the domain is, and let me highlight it. It's going to be A and C, the domain. And let's see where A and C can be located in the domain values of R as well. So you can see A here, C here, A here, C here, and I think that's it, right? So let's now, okay, now we are ready. So now we can calculate exactly. Let's now try to do the following. Let's say the first, let me say the first part I would like to have is this. Let's say this. This is the first part, okay? It's going to be all the dr pairs in T, right? That one should be very easy. That one is simply just going to be everything in T, basically, right? It's going to be A3 and also C4. Okay, and then we're going to take the union, right? It's going to be union with, and there's going to be another one. And this one, let me use maybe purple, okay? Purple over here. So let's say this part, I'm going to use purple, okay? Over here. And what about that part over there? That part is going to be all the dr pairs in R. However, the domain value cannot be a member of, the first elements, D, cannot be a member of the domain. What's the domain of T? A and C. So we're going to find out everything that's outside the domain, which is exactly those that are not green over here. Exactly what I just circled. All right, over here. Well, that's what we get a union with. So it's going to be B2. Oh, actually I circled something wrong. Let me undo it again. Beg your pardon. B2 and B5 D1, E2, and F3, right? We're going to choose all the pairs whose first element is actually not A or C, which are the domain of the T that we are trying to overriding with. All right. All right, let's now write it down. It's going to be B2 and also B5 and also D1, right? I'm running out of space. I'm putting it here. E2 and also F3. Right? That's a union. And of course, I'm pretty sure you know how to put them together, right? Union them and put them into this particular set. And you will see the complete answer on the slides, right? I think that's good enough over here. And let me highlight again before we move on to the next slides. Whenever you consider overriding, you look at R is overridden by another relation T. Think about R over here ultimately is going to keep some order pairs and also got some order pair replaced. The ones you would keep will be those whose first elements are not in the domain of the relation T over here. So that's why you can see that's the second set over here. What about this first part over here? The first part, you can think about all these over here will be gotten rid of and they will be replaced by the T over here because T got its domain T over here. We want to keep the domain T, right? So for any overlap for the first elements being the domain value over here in R, we want to replace them by T over here. So that's the first part. And then this will be the second part where it's outside the domain of T, in which case we want to be consistent with whatever that's already in R. Right? That's kind of the intuition you want to have for relational overriding. We'll give you another slightly different interpretation for the relational overriding operator in just a moment. Okay, but make sure you understand this example over here. All right, so that's exactly what I just illustrated. You can definitely take a look at the slides and to see exactly which are the two parts to form the ultimate relation over here. Of course, since the relation is a set of pairs and the set has no order, so if you put these order pairs in different orders, that's fine too, as long as you got all of them without any duplicates. Let's now move on to, before that, what about the syntax for the relational operator, for the relational overriding? All right, so you can see somehow to really to kind of look similar to this mathematical symbol over here, you can see smaller than and also plus. The plus over here tells you that there should be the line should be partially within the triangle and partially outside the triangle, basically, right? Just that's how I think of the symbol, so I don't forget. Okay. Anyway, so you're supposed to know about both the mathematical symbols over here for each relational operator and also their corresponding ASCII character, because when we use the rodent tool later in the very soon in the course, you will need to know how to enter the ASCII representation for the relational operator whenever you need it.